Welcome to Geography and Geographers. This is the second video of the series on the history of geographical thought. In the previous video, we explored Homer, whose epics offered rich descriptive images of the Mediterranean world. Homer's geography was experiential and narrative. It expressed how space was traveled, imagined, and remembered. With Thales of Miletus, writing in the early 6th century BCE, a profound epistemological shift takes place. Geography begins to move from poetic description toward rational interpretation of the earth. Thales was born around 624 BCE in Miletus, a prosperous Greek city on the Ionian coast of Asia Minor, in present-day Turkey. By the 6th century BCE, Miletus had become one of the most important commercial and intellectual centers of the Mediterranean. From as early as the 8th century BCE, the city had established an extensive network of colonies around the Black Sea and Eastern Mediterranean. This expansion produced a strong culture of navigation, maritime trade, and exploration. Milesian sailors and merchants accumulated practical knowledge of coastlines, winds, currents, seasons, and distant lands. This continuous engagement with the wider world created an empirical background that profoundly influenced the earliest attempts to conceptualize the Earth. It was within this outward-looking and intellectually dynamic environment that Thales emerged. He is widely regarded as the first Greek philosopher and the first natural scientist. From the perspective of geography, however, his importance lies not in the volume of geographical information he produced, but in the method and orientation he introduced. Before Thales, explanations of natural phenomena were largely mythopoeic. Earthquakes, floods, storms, and celestial events were commonly interpreted as expressions of divine will. Thales challenged this worldview. He proposed that nature operates according to discoverable principles and that natural events arise from natural causes. With this move, the Earth was transformed from a sacred stage of divine action into an object of rational inquiry. This epistemological shift is foundational for geography. A scientific understanding of the Earth is only possible once nature is assumed to be intelligible, structured, and open to investigation. One of Thales' most well-known propositions was his claim that the Earth is a flat disk floating upon an infinite body of water. Although scientifically incorrect, its geographical significance is considerable. Thales was not invoking a god to support the Earth. He was proposing a physical structure. The planet was treated as a material body situated within a natural medium. This represents one of the earliest attempts to conceptualize the Earth in physical and systemic terms. Closely connected to this was his doctrine that water is the arche, the primordial substance from which all things originate. Water for Thales was not symbolic, it was environmental. Seas, moisture, life, and land were conceived as interconnected expressions of a fundamental material principle. Within this framework, Thales suggested that earthquakes might result from movements in the watery foundation beneath the Earth. This stands among the earliest recorded naturalistic explanations of geological phenomena. Such thinking marks an important stage in the intellectual prehistory of physical geography. The Earth was no longer merely described, it was being theorized. Thales' inquiries were not confined to terrestrial processes. He was deeply engaged with astronomy. He studied the motions of celestial bodies, observed solstices, and attempted to understand cosmic cycles. He is famously credited with predicting a solar eclipse in 585 BCE, an event reported to have halted a battle between the Lydians and the Medes. While the exact method he used remains debated, the episode is significant because it reflects an attempt to understand celestial phenomena through patterned observation rather than divine intervention. For geography, this is crucial. In the ancient world, navigation, seasonal rhythms, agricultural cycles, and regional differentiation were inseparable from astronomical knowledge. The understanding of space, time, and environment developed together. By linking celestial regularities with earthly processes, Thales contributed to the intellectual framework from which later ideas of climatic zones, environmental rhythms, and spatial orientation would emerge. Thales also played a formative role in introducing geometry into Greek intellectual life. Through his travels to Egypt, he encountered practical geometric techniques developed for land measurement, architecture, and engineering. He transmitted this knowledge to Greece and demonstrated its application to real-world problems. The well-known account of his measuring the height of the Great Pyramid by comparing the lengths of shadows illustrates a decisive methodological development. Terrestrial space could be quantified. This moment is critical in the history of geography. Measurement lies at the heart of surveying, mapping, and spatial representation. By showing that distances and heights could be calculated through rational procedures, Thales helped open the path toward cartography and mathematical geography. The Earth was no longer only experienced and described, it became measurable space. Although none of Thales' own writings survive, his influence on subsequent thinkers is unmistakable. His insistence that the natural world could be understood through observation, reasoning, and general principles laid the foundation of what became known as the Milesian school. Anaximander's construction of one of the earliest world maps around 550 BCE, Hecataeus' systematic regional descriptions, Herodotus' environmental histories, and eventually Eratosthenes' measurement of the Earth's circumference in the 3rd century BCE all emerged from the methodological transformation initiated by Thales. From the standpoint of geographical thought, Thales occupies a transitional position. He was not yet a geographer in the disciplinary sense. He produced no systematic regional geography, no climatic classifications, and no maps. Yet he made geography possible as a discipline by transforming how the Earth itself was conceived. Thales marks the shift from experienced space to conceptualized Earth. From a world explained through myth to a world investigated through reason. From landscape as narrative to Earth as system. His enduring geographical legacy lies not in the accuracy of his theories, but in the intellectual conditions he established. That nature is ordered, that the Earth is physical, and that both can be studied. In this sense, Thales stands at the threshold of geography as a scientific way of knowing the world. His enduring geographical legacy lies not in the accuracy of his theories, but in the intellectual conditions he established, that nature is ordered, that the Earth is physical, and that both can be studied. In this sense, Thales stands at the threshold of geography as a scientific way of knowing the world. In the next video, we will move from Thales to his student, Anaximander, the first thinker to draw a map of the known world and to imagine the Earth in geometric terms. There, geography takes its next decisive step. Thank you for watching. If you find this series useful for understanding geographical thought, you may consider subscribing to the channel.